Good evening. So I'm Calvin Joseph, and I'm a second year research scholar in IIT Kharagpur, and I'll be conducting your doubt clearing sessions on network analysis subject for NPTEL, which you guys have enrolled in. And this was taught by Professor Tapas Kumar Bhattacharya of IIT Kharagpur. So you guys will be going through the video lectures, and these sessions are designed such that you've gone through the lectures and now you will have some doubts, so you can ask those doubts over here. Whatever queries and doubts you have, you can ask, as well as also we'll be solving some sums. So those sums also you can uh, learn and understand how to solve those sums. Okay, so today we'll be focusing on mesh analysis. What is a mesh, we'll understand, and how, what what law we apply for mesh analysis, and what is the technique and what are the steps you have to follow to solve a circuit using mesh analysis. Then we will consider what is a node and how we will use KCL, that is Kirchhoff's current law, to solve a circuit using nodal analysis. Okay, so then also we will consider a special case of what is a super mesh, where uh, there is a current source is there in between like two meshes are there. And also we'll consider the case of a super node where a voltage source is there between two nodes. So there is a slight modification when we go to super mesh and super node, how to solve, and that we must take into account and we must solve it. Okay, so all right, yeah. Okay, so you guys have gone through those video lectures. So what doubts do you guys have, or what problems you guys are facing? If you can let me know, then I can focus more on that.
Good evening, sir. I am Shubhakam Hota from Dreams Polytechnic, Kotak, Odisha.
Okay.
Sir, I have been doubt in Supermesh and Supernode problems.
Okay. Yes, so we'll look into that also.
Do some examples in Supermesh and Supernode.
Okay. Just hold on.
Yes, sir. Yes, sir.
Okay, so it's visible, right?
Yes, sir. Yes, sir.
And so one is super node and super mesh. You want some examples on that. Others, what doubts you guys have? Okay. So I will start with the basics. We'll understand what is a mesh, what is a node, and we will learn KVL, KCL, how to solve it, and we will go step by step. Okay. So these are some nodes which are there, mesh and nodal analysis. Okay. So you tell me what is a mesh? Like, what do you guys understand of a mesh?
Sir, mesh is a loop which does not contain another loop within it. Mesh is a loop, but which does not contain another loop within it. mesh के अंदर दूसरा कोई लूप नहीं होता है.
ठीक है. तो अगर मैं ये वाला सर्किट दिखा देता था, 1 मिनट.
हाँ.
तो मान लो ये सर्किट है.
Yes, sir. Yes, sir.
So how many meshes does this circuit have?
Sir, three meshes. There are three meshes, sir.
Okay, so there are 3 meshes. And for
Yes, sir.
mesh analysis, what we will apply? We will apply KVL or KCL?
We are applying the KVL.
Okay.
We can solve with KVL and we can also solve with KCL.
Okay.
If you goes with the mesh analysis, then we are using the KVL.
Okay. So now can invert. Okay, you guys apply KVL for mesh 1. When you apply KVL to mesh 1, what you will get?
Sir, current, we are getting, sir, I am considering the first symbol. So minus I1 R1 plus
Okay.
I1 plus R2 whole into I1 minus I3 plus E1
No, plus R2 what?
plus सर मैं फिर से बोल रहा हूँ माइनस सर आपने सेकंड सिंबल लिया है, ठीक है, मैं सेकंड सिंबल लेकर बोल रहा हूँ माइनस I1 R1
Mm-hmm.
उसके बाद सर आपने पहला जो है जो R1 में जो ड्रॉप हो रहा है उसका
Mm-hmm.
आपने सेकंड सिंबल लिया है। तो सबका सेकंड सिंबल हम लेंगे तो माइनस I1 R1 उसके बाद सर करंट I1 में इसके नाम लिख लेंगे तो I1 करंट को बढ़ा देंगे सेकंड सिंबल उसका माइनस है माइनस I1 माइनस होल इंटू I1 माइनस I3 इंटू R2 वहां पर लेट करंट होगा I1 माइनस I3 इंटू R2 ड्रॉप होगा नेट ड्रॉप
Okay.
R2 होल इंटू I1 माइनस I3
Acha, actually, it's not clear. So I'll just write it down. Okay. So,
sir, we can take the when we are adding the voltages, we can take the first symbol, either take the first symbol or the second symbol. If
okay.
taking the second symbol of the voltage drop, then all the voltage drop will be taken as the second symbol.
Okay. I'll write it down and I'll explain. Okay. So, what happens
Yes,
is in mesh analysis, let me consider that I'm starting from here. Okay. This is my mesh. I'm
yes, sir,
starting
yes,
from
sir.
this point.
From R1.
Yes. Okay, this is Britika has also written something. Okay, you can write that in the chat. Okay, I'll go step by step. So I am starting from this point, and I have to I have to travel according to this whole path, and I have to reach back over here. So that is my KVL. So what I'll do is I'll apply KVL in the mesh 1. Okay. So my current is in this direction. So my current is flowing from this point to this point. So the potential is reducing. So I put a minus sign. So I'm going in
Okay.
this direction where the current is flowing. So that's why I put a minus sign. So it goes minus I1 into R1. Next, I am going
Yes, sir.
from this point to this point. Okay. Pen is make this big, no problem. So I'm going, let us assume I'm going from this point. I'm going to this point. So I have to travel through R2. So what happens, that voltage drop across R2, I have to find out. Now, what is the
Yes, sir.
current to R2?
I1 minus I2.
Okay. And that current, no, it's not minus I1 minus I2, it is I1 minus I3.
Sir, in R2.
Yes, in R2.
Yes, sir, yes, sir. You are taking the one of okay, sir. I3.
Yes. So that's why it will be, and I am considering that the current is flowing in this direction. So the current flowing in this direction is what? That current flowing is I1, which is in this direction, and this I3 is in this direction, in the opposite direction. So that current is I1 minus I3.
I1
So,
minus I3.
so this is the current flowing through my resistor R2. Okay. So
2.
when I apply
Four.
KVL in from here to here, like I'm applying the voltage, so it will be minus, because I'm considering the current is flowing in this direction. So it will be minus, what is the current? That is I1 minus I
Minus I3.
into R2.
R2.
Okay. Now I am
Yes,
going
sir.
from positive to negative. Now I have come over here. Now I have to go from here. I have to reach this point. Okay. So when I'm going
Yes,
from here
sir.
to here, there is a voltage source, or you can consider it to be a battery. Okay, there's a battery. So I'm going from the
Yes,
positive
sir. Yes.
to the negative terminal of the battery.
Negative.
So it will be minus E1. Okay,
Minus E1.
minus
Yes, sir.
1. Now I am going from this dot to this dot. Okay, to this point in the circuit. So I am
Yes,
going
sir.
through 3. So what is the current through R3 in this direction?
I1 minus I2.
Okay, so that is equal to I1 minus I2. So that will be minus of R3 into I1 minus I2, which is equal to 0. Okay, because I've again come back to this point. Hmm. Is that clear? Okay. So,
Yes, sir. Yes, sir.
okay, so, uh, okay, let others also talk. Let others also ask the doubts. Okay. Yeah. Everyone ask your doubts. Okay. So now this is my circuit. This is the equation which I've got. So now what do we do is we will write it in terms of I1, I2, I3, and E1. Okay. So what do we do first? I see that all the negative, 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 negative all are there. What I do is, okay, first what I'll do, I'll open the bracket. So this bracket is there, this bracket is there, I'll open that bracket. So first what I'll do, this will be minus I1 R1. Okay. Then this will be minus I1 R2. Minus minus becomes plus. So this becomes plus I3 into R2. Okay. Then minus E1 remains as it is. Then it becomes minus I1 into R3 minus minus, so plus. So it becomes plus I2 into R3 is equal to 0. So this is what I've done is I've gone step by step. I have first written the equation here. Okay. Then I have opened the brackets over here. Now what can I do is if I want to write it in a better form, I can group what is I1. What is for I1, I will group it. So I will take I1 a common. So I'll do minus of I1. Okay, what is for I1? There is R1 is there. Then there is R2 is there. So plus R2. Then R3 is there. So plus R3. Okay. So whatever is for I1, I have grouped it all together. Next, I will go for I2. For I2, it is just simple plus I2 into R3. So I will write it as plus I2 into R3. Next, I will consider for I3. So I3 has I3 into R2. There's no other place I3 is coming. So I write it down as plus I3 into R2. And this is minus E1 is equal to 0. Okay. Now, what I can do is I can take this E1 to this side that is in that I can consider. So I write it down as minus I1 into R1 plus R2 plus R3 plus I2 into R3 plus I3 into R2 is equal to E1. Okay. So for this course, when you will be you will be solving and answering as such, it is like mostly MCQ. Okay. It is not, it is MCQ and some numerical answers. But suppose you are going like you're giving exams for college. Okay. In your BTech second semester or first semester, whenever you're giving exams, you are required to write the steps. Okay, your steps should be there and it should be in a neat fashion. Okay, so what I used to do when I was in my BTech, I will number the equation. I will number the equation as equation one. So whenever I want to use equation one, I can refer to it. Okay. So it is not something random. So whenever you're going to use this equation one, you have to write down in your answer sheet, in your exam sheet, that I am using equation one or substituting in equation one or adding equation one and equation two. So those are the basic steps. Okay. So those steps are required when you're solving for your semester exams, etc. So till here, anyone has any queries or any doubts, you can ask me. And one more thing, this someone had sent some message. Who was that? Okay. R1 plus R2 plus R3 into I1. Okay. Minus R3 into I2 minus R2 into I3 is equal to minus E1. Yes, it is correct. Only the polarity has been changed. Okay. So till here, anyone has any queries?
No, sir. No, sir.
Okay. So like that, you have to write the equations. So now what you must remember is you will be given some random circuit. Okay. Suppose you are given this circuit like this. Hmm. So how many meshes are there in this circuit?
Two meshes.
Yes,
Two
there are two
meshes.
meshes. So what I will do is, my first step, I will identify that there are two meshes. Then I have to assign currents to each of the mesh. Okay, so I will add current in the clockwise direction is the preferred notation. And in your exam, in your NPTEL exam, in the questions, it will be given what direction the current is flowing. Okay, so we assume it is in this direction. So this is I1, this is I2. Okay, now I have written this. Now solve and tell me what will be the KVL when I apply it for this mesh 1.
Minus R1 I1 minus
No, no, no.
R2 I1
Minus I1 R1 minus I1 R2,
R2 I1
then
minus R4 into
uh,
I1 minus I2
yes, then
minus E1 equal to 0.
okay, minus E1 equal to 0. Okay, so this is correct. So what you have to remember while solving is the direction in which you are going and how you must assign the correct polarities. All right. Now assume I am finding, yes, correct. Pawan also has got it correct. Okay. So now for KVL in mesh 2, so how am I doing it? I'll show you. So I'm going to apply KVL in mesh 2. I'm going from here. I will be going in this direction. So it is going from the negative of the battery to the positive of the battery. So I'll write plus. So it is E1. It is plus E1. Okay. It is plus E1. Okay. Now I am going like this in this direction. So what is the current through R4 in this direction? That will be I2 minus I1 because I2 is going upwards while I1 is going downwards and I am going in the upward direction. So the effective current in the upward direction in resistor R4 is I2 minus I1. So I will write it as minus of I2 minus I1 into R4. Okay, next I'm going from here to here and I'm going in the right direction. And my current I2 also is going in the right direction. So I will write it as minus I2 into R3 is equal to 0. Okay, so when you simplify this, you will get E1 plus I1 into R4 minus I2 into R3 plus R4 is equal to 0. Okay. So Pawan has got minus I1 into R4, correct, plus I2 into R3 plus R4. So this, if it goes here, be minus E1 and then into minus E1. Yes, okay, so this is correct. So Pawan also has got it correct. Okay, all right. So any queries in this?
No, sir.
Okay, what about others? There are many people over here. Okay, so you guys can, if you have doubts, if you have any problem, you can ask me because this is a very basic thing. You must not make a mistake in the notation. You must understand how. If you are going from the negative of the battery to the positive of the battery, you have to consider positive. If you're going from the positive of the battery to negative of the battery, you must consider minus. Similarly, for the current, when it is in the direction in which you are going, then you have to consider minus, right? So this is very important. These equations, you must get it correct. If you get it wrong, some sign is wrong, your answer is wrong, and it's very hard. All right, so this is the basic step. Okay, so now this is for the KVL which we have applied. Now let us look for one. Okay. Now can anyone tell how many nodes are there in this mesh?
One, sir, two nodes.
Two nodes are there. Okay.
Yes, sir.
Where are those nodes located?
R1, the junction of the R2, R3, and R4. And the second one is the junction of the R1, E1, and R3.
R1, E1, and R3. Okay, this is also one node is there. Fine.
And in the upper lower part, R1, E1, R3. The junction of the R1, E1, and R3.
Yes.
So
Another
there are
node.
nodes, total two nodes. In that, one will be acting like a reference node.
Yes, yes. So we will consider, yes, so one node will be considered to be the reference. Okay. So now, so now in nodal analysis, if I want to do, I've done mesh analysis. Okay. I've done mesh analysis and I have found out currents I1, I2. Assume I want to do nodal analysis. So what will be my unknown quantity? Here in mesh analysis, my unknown quantity was I1 and I2. In
Current.
nodal,
Yes, sir.
is
In
then,
nodal, the unknown quantity is V1 and V2.
okay. So here,
Node voltage.
here the unknown quantity will only be V1. Okay, this is your reference. This is okay. Hmm. So you will find that voltage V1, you will apply KCL. So how will you apply KCL for this? Okay, mute, please mute if you're outside. Now, assume I want to apply KVL, KCL, sorry, KCL. What will be KCL? If I want to apply KCL at this node, what will it be?
V divided by R1 plus R2. If
Uh,
and if I take a current direction, okay, one is entering, another one is leaving. That should be equal to
uh,
again V divided by R3.
uh,
I think it should be plus V1 by R1 plus R2 plus V1 V minus E1 by
V minus V minus
V
E1
minus
divided by
E1
R4.
by R4.
okay. Okay, so there's V1 by R1 plus R2 plus V1 by, okay, so there'll be plus V1 by R3 plus V1
Equals
minus
to
V1 upon R4. This
equals
should be
to
equal to 0.
0.
Okay. Okay. So anyone has any, okay, so let me just explain this equation. So what it means is this V1 by R1 plus R2 is what? Sorry, so what does this V1 by R1 plus R2 mean?
That is the current flowing in that.
Current, sir, current.
Yes. So if I look at this node,
R4 branch.
I have one current going in this direction, that is V1 by R1 plus R2. I have another current flowing in this direction, that is V1 minus E1 by R4. Another current flowing in this direction, that is V1 by R3. Okay. And the total sum of that is equal to 0. Okay, so actually I'll make a new example and we'll go. Also, I'd like to let you guys know that this is a Zoom meeting, so there's a limit of 40 minutes. All right. So once the 40 minutes are done, it will go off. So I'll restart the meeting again. So you'll have to join in the same link. All right. Okay, so yeah, that's that. And so now we'll go to the next page. Okay. Okay, so now new page. So now let us consider nodal analysis. We'll take a better example, another example. Mm, okay, so how many nodes are in this circuit?
3 nodes.
3 nodes are there.
3 nodes.
So we'll consider this to be my reference node. Okay.
Three nodes.
Yes. So this is my reference node. So this node will be my V1 node. This will be my V2. This is the potential at that node with respect to this node. Okay. So now I'll apply KCL at this node. Okay, I apply KCL at node 1. So what does KCL say? That the total current entering into a node should be equal to the total current leaving the node. Okay. So how I solve it is I will consider that all the currents are leaving the node. I'll assume the current is leaving the
Yes,
node.
sir.
This current is leaving the node here. This current is
Yes,
leaving the
sir.
node. So I use a standard thing
Yes,
that
sir.
I consider that all the currents are leaving the node. So what I do? So I add this is the current leaving. This is what?
D1 by
E1 by R.
outgoing. D1 by R1
Okay. And for current
plus
one is how much?
uh, plus V1 plus E1.
V1 minus E1 divided by R2.
Okay. So what happens is this is V1. Okay. And this is plus means it is
E1
opposing.
minus E1.
So it is opposing it. So that's why it will be V1 minus
Minus E1 divided by
by
R2.
R2. Okay.
Again plus
Plus
V1 minus V2
V1
divided by R3. That is all
equals to
equal
0.
to 0.
0.
So this all is equal to 0. Because I have considered that all the currents are leaving the node, so no current is entering the node, so that should be equal to 0. Okay. So does anyone else have? So is this point clear? So now I have applied KCL at
Yes,
node.
sir.
Then I will rearrange it and put in terms of V1, V2, E1, etc. That we will look into later when we will solve the sum. Now let us consider KCL at node 2. KCL at node 2. When I apply KCL at node 2, again I consider that all the currents are leaving it. So what happens? This current is leaving this. This current is also leaving the node. This current also is leaving the node. So first, what is the current going from here to here? What is that current?
V2 minus V1 divided by R3.
So this is V2 minus V1 divided by R3.
Plus V2 divided by R2.
V2 minus V1 divided plus. Now this is current is V2 by R4. V2 by
R4
by R4 and V2 plus E2
plus E2 by R5
equals to 0.
So this will be V2 plus E2.
Plus E2 divided by
plus
R4.
E2.
So this is aiding it, like this is helping it. So it becomes V2 plus E2 divided by R5 is equal to 0. Right. So to hear us, is it clear for everyone?
Yes, sir. Yes, sir.
Okay, so there are many people. There's Subrajit, Shivani is there, Vinod is there, Nida is there, Divya is there, Chandra is there. So all of you guys, if you have any queries, you let me know. Okay, what you're not able to understand. Right, and yes. Also, I will actually, after this session is done, the videos I will upload on YouTube. And also this sheet this file. I will also upload on my Google Drive. So I'll give you those links for that. So the channel link is this. So this is my channel link. So over here the videos will be uploaded, and this is the drive link. Okay, and the drive link is over here. So here are these notes will be uploaded later. Okay. Yeah. So you guys can access it and check it, right? For further reference if you need. Now we will consider a case of a super mesh. Okay, we will consider a case that there is a super mesh. So let us assume we have what is a super mesh. So we have okay, please be muted. Okay, assume this example is there. Okay, and they have told you have to solve it using mesh analysis. Okay, so how will you start?
Give the current direction for the meshes.
Okay, so I will consider how many meshes are there first?
3.
3 meshes.
Method.
So this is one mesh, I1. This is another mesh. This is I2. This is another mesh. This is I3. Okay. Now, among this, which is my super mesh?
1 and 2.
1 and 2 together form the super mesh. All right.
Supermesh.
So now, this question, okay. One thing is easy for us to find out I3. What will be the value of I3?
IB.
IB.
So I have already found out that I3 is equal to IB. That's how I found, because I3 is flowing in the current direction of IB and is the only current. So that I3 is equal to IB. What is IA?
I2 minus I1.
So IA is equal to I2 minus I1. Now, so I have found, so how many unknowns are there in this circuit? How many things I don't know and I want to find?
2 I1 and I2.
Okay, there are 2. Yeah, I3 also was unknown, but it was easily found out to be IB. So that is fine. Now I have found, so there, now let us consider there are 2 unknowns. So this is equation 1. I found out equation 1. Now I need to find equation 2. Now, if you forgot or if you didn't know that there is something known as super mesh and you try to apply KVL in mesh 1. So how you would have gone, you would have gone from here, let us assume start from here. So you would have written minus I1 into R1. Then you'd be going from here to here. So it will be plus E1.
E1.
Till here it is all fine, very smooth, very correct. But now when you want to find the voltage, across this current source, you don't know. You don't know what is the voltage across this current source. It is not given and you cannot know it. through that. So because you cannot know the voltage across this current source, what you do instead is you apply KVL across this entire super mesh. Okay, you apply KVL across this entire super mesh, right? So see, it is not, you cannot say that KVL is not applicable in mesh 1. It is applicable in mesh 1, but the voltage across this current source is unknown. Okay, you cannot find it. Like it is not given. It cannot be written in some sort of equation form. That is why what you do is you find the KVL across the entire super mesh. Is there any doubts in this part?
No, sir.
So now this will be plus E1. Now I'm going to go from, I've come till here and I cannot go in this direction. I cannot go like this. I have to proceed like this. So what I do, I will go from here to here, from here to here. So what is my current? It is I2 in this direction. So what I do is I'll apply KVL, I'll continue applying. So I'm over here, I'm going to go over here. So it is I2 is in this direction. So I write it down as minus I2 into R2. Okay. Then I am going from,
So minus I2 plus I3 into R4, na?
okay, minus I2 R2. Then it will be,
Minus E2.
this will be it will be minus E2 because I am going from the positive to the negative. Then
Okay.
I am going
Minus
to go through
minus
here.
minus I2 plus I3 into R4 equals to 0.
So it will be, let me do bracket. So now I'm going to find a current flowing like this. So that current is I2 minus I4. So that will be
Minus
I2
I3.
minus, sorry, my
Minus
I2 minus
I3
I3 into
into
R4
R4.
is equal
4
to 0.
equals to 0.
Okay. So now let us rearrange it. We will group, and I3 I don't need to write because I3 is equal to IB. So I write it down as IB. Okay, since I know I3 is equal to IB. Okay. There is no. So what I will group it all together. So I will write minus I1 into R1, then minus I2 into R2 plus R4 plus E1 minus E2 plus IB into R4 is equal to 0. Okay. Yeah. So this is how we have found. So in this equation, I1 is unknown, I2 is unknown, E1 minus E2 and IB R4 all are known. Okay. And from here also we have I2 minus I1. So this will be equation 2. So I'll have to solve equation 1 and equation 2 and then I will get my I1 and I2. Hmm? So any queries in this? Anyone? So only Pawan is answering. What about others? Others also should answer. This session should be interactive so that I'll know like what you guys are understanding, what is difficult, where and all you're facing errors. They should let me know. Okay. Yeah. So now we have seen what is a super mesh. Now we will see what is a super node. So Okay. So in this circuit, how many nodes are there?
Two
Three nodes, sir.
There are three
with
nodes.
one reference node. Yeah, three.
There's
Three
three
nodes.
nodes, but this is my reference node. Okay. This is my reference node. So now, but the problem, so let us just start. I'll assume I apply KCL at node A. I'll ignore the fact that it is a supernode, that it is part of a supernode. So if I want to apply KCL at node A, I will have one current going out like this, another current going out like this. Okay.
Like this.
And one current which is going like this. So I will start. I will do VA divided by R2 plus VA minus E2. So please mute if you're outside. VA minus E2 divided by R1. So till here it is fine. But now I don't know what is the current flowing from here to here. So I get stuck. I don't know what is the current from here to here. So now I realize that this is a supernode. So now what happens in a supernode is you club both of these together. This whole entire thing, you club it as one node. Okay, you say this is just only one node. You assume that this entire thing is a one node, and you consider that, and then when you apply KCL over there, we use the same thing. If there's one node, what do? We assume all the currents going out is equal to all the currents entering the node. And what is the way I prefer is I prefer that I assume that all the currents are going out. So for this super node, if I want all the currents to be going out, so this current is going out here, this current is going out here, this current also has to go out, and this current also has to go out. Okay. So I have given the direction for the currents that all the currents are going out. So now I will write the equations for those currents. So now for this current, what will be the current going down? Can anyone tell me?
Sir.
What is the current going down here?
Between A, B.
Now from here to here, what is the current flowing?
Sir, pen mark is not. From B to reference.
From VB to the reference, what current is flowing?
Minus I2. From reference to B, I2.
Okay, so this is
Minus I2.
I2. And the current going out here is I2. So this becomes
Yeah.
minus I2 plus I2 is equal to 0. Okay. No. There's a mistake there. 1 minute.
Sir, this
Yes.
sir, already the I2 current is incoming current. So after so there are three outgoing currents and one current is incoming, that is the I2. So sum of the incoming equal to I2.
That means like minus I2 plus VB by R4,
Plus
and we
VB.
can't able to write from VB to VA because we don't know the current there. No?
Okay, so it is the case. So what I have is I have VA by R2, which is current going in this direction. I have VA minus E2 by R1, which is a current going in this direction. Then I have from here to
In R4.
This is just I2 is coming in. So what is the current going out? That will be minus I2. So I have written it as minus I2. Now,
minus I2.
The current going from here to here, that is VB by
R4.
This is equal to 0. Okay.
Yes, sir.
So this is how for a supernode you can solve it. So does anyone have any query, anything? Because there are 20 people, but only 1 or 2 people
Can you come again here? I have a doubt here.
Yes.
With reference to node A, yes, it is VA by R2 plus VA minus E2 divided by R1, and we can't able to apply because there are two in between A and B we have a voltage source, so it will become a supernode. So once it becomes a supernode, what is the procedure to next step?
So it has become a super node. So we consider this entire thing to be one node. Okay, it should be one node. So we treat it as one node.
Which
Okay.
is one node? I couldn't able to.
This both of these together they form a super node. Both of these together they form a super node.
Of course, A,
A, B are the one node.
yeah, A and B will become one voltage. Is that what you're saying?
It won't become one voltage, it will become one super node. Okay, and the voltage difference between them is known. It is not that it
So
is
there
not.
will be one more equation. I think there will be one more equation. Only one equation you have written. I think
Yes,
one
yes.
more equation
Yes,
will
there
be
will be
there.
one more equation.
So it's an incomplete. I think one
It's
equation is
only an
because
input
supernode
in
for supernode
outgoing current you have
From
mentioned.
for
from
supernode you
supernode,
have said that
we have write
it
one
become one
another
node.
equation.
It become one node. So there will be relation between VA, VB, and E1. So that will be one equation, and then only we can solve it.
Yes, yes. Okay.
That is VB minus
So what will
VB
be
minus
second
VA
equation?
equal to
I
E1.
think it will be
VB minus VA by
minus.
E1. VB
Not
minus
by,
VA
I
by
think.
E1.
Okay.
No, I think VB minus VA is equal to E1. I think it's not.
E1.
It will not be.
This is right.
It will not be in denominator. It will be equal to E1. I think.
Yes, okay.
VB minus V1 VA equal to E1.
Yes. Okay. So yeah, so that is the relation between these two nodes. Okay, Pawan, you were saying something. Your doubt is clear or what?
Yeah, like my question is like once two nodes has become a supernode, then how do you write an equation there? You're just saying that you just have to consider that B as a thing, and then you have taken the current is entering the reference, and it is going out back. No, it's going away from the node B, so you have taken it as minus I2.
Yes.
And again, from the reference node from the B to reference node, it is going away. That's why it is VB minus 0 divided by R4. It is nothing but VB by R4.
Yes.
That should be equal to 0. How it will be
Yes.
equal to 0? That's my question. Because there is a supernode between B and A, na?
There's a supernode between B and A. So if you look at an so why do we make it a supernode? Because we don't know what is the current flowing over here. Okay, let us consider. I assume that current flowing like this is Ix. Assume it is Ix. Right? Current coming here also is Ix. That is fine. So now let me apply KCL at node A. What I will get? I will get it as VA upon R2 plus VA minus E2 upon R1 plus Ix is equal to 0. This I got.
Okay.
Next, I will apply KCL at node B.
Oh, it will become minus. Okay. I understood.
Okay, let me just show for completeness. So it becomes Ix, that is current entering in, is equal to, okay, so Ix, let us assume this is Ix plus I2, and the current going out is VB by R4. So that will be equal to VB by R4. So when I subtract this from here, what I will get? So this is, suppose this is equation 1. This is equation 2. Okay, so now
I guess if I apply it to the node A, it should be minus. It is coming towards, and both are going outside. So that means like minus Ix equals to I'm sorry, minus I2 plus VB by R4 equal to minus Ix. Correct, na?
Minus I2 plus VB by R4 is equal to Ix. Yes.
Yeah.
Okay. So what you do is this. So what you do, you subtract 1 and 2. Okay. There's another way. I write Ix is equal to minus I2 plus VB by R4. Okay. Now what I do, this is my equation 2. I put equation 2 in equation 1. That is, I substitute the value of Ix in equation 1. So I get it as VA upon R2 plus VA minus E2 upon R1 minus I2 plus VB upon R4 is equal to 0. Okay, so that is the same as this original equation. So to skip this extra step of writing this and then eliminating it, we just directly consider it to be one node and then we solve it. It's not one node, we consider it to be a supernode and we solve it. Okay. So I hope that answers your question. Then one more thing is, now there are two unknowns. Okay, what are the two unknowns? So VA is unknown and VB is unknown, but I have only one equation. So I need to get another equation. So what is the difference between this point and this point? It is
VB minus VA equal to E1.
Yes. So it will be VB minus VA is equal to E1.
E1.
So using this equation and using this equation, I can get the values of VB and VA. So I hope all this is clear. Or is there any
Yes, sir. Yes, sir.
queries? Yeah. What about the others? No one else is asking any question, answering. Lalita, Saujanya, Ashwat, Misbah. Guys know it, don't have any queries. Okay. So yes, this is done. Now we'll solve one example sum. Okay, we'll solve one question. Okay, let us consider this example. This circuit we'll consider. So this circuit is there and they have told us solve the following circuit using mesh analysis. Okay, we have to do mesh analysis and we have to solve the circuit. So how will you solve this circuit? Can you tell me?
So there are 4 number of meshes. First we consider the unknown mesh currents.
Norbert?
Unknown mesh current. There are 4 number of meshes. So first we consider unknown four currents. In mesh 1 already current is given I1 equal to 3 ampere. We can apply the KVL in mesh 2, but mesh 3 and mesh 4 is a super mesh as 2 ampere is in between them. So mesh 2 and mesh 3 and mesh 4 take as the super mesh. I1 current is already known, that is 3 ampere.
I'll draw it so everyone can understand. So this is I1. Okay. This is my direction I2. This is, let us say, this is my I3 and this is my I4. Okay. So first thing we know is I1 is equal to 3. That was simple. That has made our life a little simpler. Next, what do we know is this node, this mesh. So we will apply KVL in node in mesh 2. Then we will also apply KVL in mesh 3 and mesh 4 also we want to apply KVL. But you see there is a current source over here. And because of that current source, we cannot apply KVL to mesh 3 and mesh 4 individually. So what do? We apply KVL collectively to the entire super mesh, which is formed by mesh 3 and mesh 4. Okay. Another thing we know is now this current is going in the downward direction. Okay. So what is the current in terms of I4 and I3?
I4 and I3.
So it
I4 minus I3 is
I4 minus I3 equal to 2.
yes. So it is I4 minus I3 is equal to 2. So good, others also are talking. So
Equal to 2.
it should not just be Shivam is doing all the talking, others also should answer. Okay. Others also are smart. So it is I4 going down minus I3 because it is going upward is equal to 2. Okay, so I have got this. Now I'll apply KVL in mesh 2. I will apply KVL in mesh 2. Let us note down this. This is 1. This is for reference. Now I'll apply KVL in mesh 2. I'm going from here to
Yes,
here.
sir.
So resistance is 3 ohms. So I'll take minus 3. And current in
Minus
direction of
3,
minus.
I2 minus I1.
Okay, so I2 minus
I2
I.
minus I1.
But since I1 is known to be 3, I write it as I2.
I2 minus I1.
Next, I am going from here.
Minus 8 into I2.
Yes. So this will be minus 8 into I.
8 into I2.
Then I am going from here to here. So it will be
Minus
5 into
5 into I2 minus I3.
Okay, it will be
I2 minus I3.
minus I3. And it's again come back to the same point. So this is equal to 0.
Is equal to 0.
Yes. Okay. So this
Yes,
is
sir.
the KVL we have applied over here. Now, okay. So now what I do is I have to simplify it. One way I prefer to do it is, since all are negative, what I do is I write it as 3 into I2 minus 3 plus 8 into I2 plus 5 into I2 minus I3 is equal to 0. So what I have done, I have multiplied this line, this equation by minus 1. So if I multiply minus 1 by this, minus and minus becomes plus. So this is plus, minus and minus of this also becomes plus, plus, minus and minus of this becomes plus. So I get a plus here. Minus of 0 is equal to 0. That I don't need to be worried of that. Okay. So this has become equal to 0. Now I open the brackets. So this becomes 3I2 minus 9 plus 8I2 plus 5I2 minus 5I3 is equal to 0. Okay. So now whatever is for I2, I combine. So 3 plus 8 is 11 plus 5 is 16. So it comes out to be 16I2. Then I3 is 1. So minus 5I3. Then this 9, I take it to the other side. So it becomes plus 9. So this is my equation 2. Okay. So is this clear?
Yes, sir.
Okay. Okay. Good. So this is one equation. All right. So now I applied KVL at node in mesh 2. Now I want to apply KVL to the super mesh. I'll apply KVL over here and I'll apply KVL throughout. I will apply KVL. So what I do is just drop it a bit. So I will let me start from here. So I'm starting from this point and I will go. So I will go from here to here. So since I'm going from the negative of the battery to the positive of the battery, I write it as plus 10. So this is plus 10. Now this node at this point and this point are the same. It is the same node. Okay, so I've reached over here. Is my pen visible or is it not clear? That's my query. Is this visible? Okay, so this is visible, but this small, this is very tiny. Now I think it might be still this small. All right. So now I'm going from this point over here. I'm going to come to this point, right? Okay, red I'll use. Okay. Now is it slightly visible? So it is over here. This going from, I'm going from here. I have to go to this node. Okay. So it becomes minus of 5. And what is the current? Use zero. What is the current going in the upward direction? What is the current going in the upward direction?
I3 minus I2.
So this will be, I'm using red ink. Okay. So this will be I3 minus I2. So now I have reached this point. Now I want to go from this point. I want to come over here. Okay. So I am going from the negative of the battery to the positive of the battery. So I write it
Plus
this down as plus 20. Okay. Now I'll come over here. Now I want to go back over here. So I have to pass through this 5 ohm resistor. And what is that? And I'm going from right to left. And what is the current flowing from the right to the left? What is that current?
minus 5U.
So minus 5
I4.
I4. Okay. And now I again come back to this point. So I write it down as equal to 0.
Sir, it is problem of Supermesh. I think 2 ampere current will be there.
Where? 2 ampere current will be there?
In 5 ohm resistance.
No. See. That, yeah. So Levy's is good. Getting some doubts. So current in the mesh is I3. Current in this mesh is I4. Now the current flowing through the current source is equal to I4 minus I3 is equal to 2. Suppose you apply KCL over here. Okay, you apply KCL at this node. So this is I3, this is equal to I4, and this is 2. Okay, so I4 is equal to I3 plus 2. Okay, so I3 current is coming like this, and 2 ampere is getting added, and that effectively is my I4. It is not that I4 plus 2 is flowing. Okay.
Okay.
Yeah. Okay. Lalita, you have any doubts?
No, it's fine.
Fine. Okay. So now I will simplify this. Okay. So I write it down as 10 plus 20. So 30. I'll open the bracket. So it becomes minus 5i3 plus 5i2 minus 5i4 is equal to 0. Okay. This is my equation 3. So I have 3 unknowns. So I1 I know, I3 I don't know, I4 I don't know, and I2 I don't know. So this is my equation 1, this is my equation 2, and this is my equation 3. So now I have to solve this step by step. Okay. So how will we solve it? What are your suggestions?
I4 can be replaced by I3 plus 2.
Yeah. Okay. So what I do is this, I replace, I know, okay, the meeting will end in 10 minutes, then the meeting will stop, then I'll again start the meeting. Okay. So just for telling you guys, let's save this to the new page. So what I do, I know I4 is equal to I3 plus 2 is known. I will substitute that over here. So I write it down as 30 minus 5i3 plus 5i2 minus 5 into what is I4? I3 plus 2. So I write it down as I3 plus 2 is equal to 0. Okay. Now, let me try to make this a little bit simpler. If you see this equation, there is 5, there is 5, there is 5, there is 30. And 30 is a multiple of 5. So if I divide, I will divide my equation by 5. So throughout, if I'm saying that I'm going to divide my equation by 5, I have to divide all the elements in the equation by 5. I'm dividing by 5 means what? 30 divided by 5 is how much?
6.
6. Minus 5 I3 divided by 5 is how much?
Minus I3.
So it will be minus I3. Okay. 5 I2 divided by 5 will become I2. And over here, if I divide by 5, how much it will become? So I have minus 5 bracket I3 plus 2 and I'm dividing by 5. What I should get?
Minus in bracket I3 plus 2.
So the things inside the bracket are not getting divided because 5 is a common factor. Okay. Now I have divided the left hand side of my equation, but I also have to divide my right hand side. So I do 0 divided by 5. And
0.
you divide 0 by any number, it will still be 0. Okay. So that still remains as 0. Okay. So this was what was done. Then now I will open my bracket. So it becomes 6 minus I3 plus I2 minus I3 minus 2. Okay. Sometimes we miss it. We consider minus n for the first sign, for the first element. But for the second one, we forget. Okay. So all these things we must carefully do. Okay. So this becomes equal to 0. Now I will write it down as, now 6 minus 2 is 4. Okay. 4 plus I2 minus 2I3 is equal to 0. Okay. So I've got 4 plus I2 minus 2I3 is equal to 0. So what I do next is I put I2 is equal to 2I3 minus 4. This is my new equation I have got. So I2 I have got in terms of I3 and some value. Now I will substitute I2, which is equation 4, into equation 2. What does equation 2? It says 16I2 minus 5I3 is equal to 9. Okay. So I put I2 over here. So it becomes 16 into 2I3 minus 4 minus 5I3 is equal to 9. Okay. What I've done, I've just substituted I2 is 2I3 minus 4 over here. So it comes as now 16 into 2I3. What is 6? So this is my equation. Now I have to open the bracket. So when I open the bracket, 16 into 2I3 becomes how much?
32I3.
Yes, so this becomes 32I3. Then 16 into 4 becomes 64.
64.
Okay? So this becomes minus 64. Then this is minus 5I3 is equal to 9. Okay. So now what I have done, I've effectively got it in terms of I3 alone. So I get the value of I3 by solving this equation. So this becomes 27I3 and I take 64 that side, becomes 64 plus 9. This becomes equal to 27I3 is equal to 73. Now take out your calculators and tell me what is 73 divided by 27.
2.7.
Okay, little bit more with decimals would be better. Okay, so that comes out to be 2 points. So this comes out to be 2.7037 ampere. Okay. So again, like when you consider you're giving an exam, see you have two things. Either you're using this for the NPTEL course, you're getting the certification, or some students also learning so that they can write in their exams for their BTech college exams. So when you find something, you must always write the unit of that thing. That is a simple, when you solve any sum, physics, chemistry, maths, or electrical also, network analysis also, you have to write the quantity. What is the unit? Okay. And many times in the NPTEL also, they ask they'll say, tell us the current I3. But you must read the question properly, because it may say that you have to find the current I3 in terms of milliampere. Suppose they tell you you have to find the current I3 in terms of milliampere. Okay. So if then, and you don't know, and you just write 2.7037, then your answer is wrong. If I want this to be written in terms of milliampere, what should I do? Can anyone tell me?
2703.7.
Yes. So if it has to be converted to milliampere, I have to multiply by 1000. So this becomes 2703.7 milliampere. Okay. So that's why the decimal point also sometimes is important. Yeah? So if they say you have to tell what is the current I3 in terms of milliampere, that you must see in the NPTEL thing. They ask that specifically, they specify which unit, milliampere, ampere, all that. So that you have to be watchful. So there you have to write 2703.7. Okay. They also tell in the question that we want the answer up to 2 decimals or 2 units after decimal. So if they say they want it in terms like uh, 2 more digits after decimal, you must write 2703.70. Okay. Like that, you have to try for to be accurate. So one thing is you have to try to be accurate. And because there could be, some multiplication, division, some error can be there in your calculations. So you might have rounded off somewhere or something. NPTEL has a plus or minus 5% or plus or minus 10% tolerance. Suppose the correct answer was, assume the correct answer is 10. Okay. It considers a 10% tolerance. So even if you give an answer which is 9, or even if you give an answer which is 11, your answer will be correct. You will get marks, because it is within that plus or minus 10% tolerance. Okay. So I am not exactly sure. Remember what is the exact tolerance which is given. I think it is like plus or minus 5% or plus or minus 10%. Okay. So that's why it's preferable to be as accurate as possible, so that your answer comes within that tolerance band, so that your answer comes correct. So in the NPTEL, there is either MCQ or there is this numerical answer. Okay, numeric answer. So in the numeric answer, there's this tolerance is given. Okay. Yeah. So now I have got, so any queries regarding this? Okay, any doubts regarding this, you let me know regarding the tolerance and things, because you should, like, because you will be giving the exam. Hopefully all of you will be giving the exam and getting the certificate. And the date also has come. Date has come to be some 21st April or something. The email also has come. Yeah.
Can you scroll up a little? Let me look once again. I'm sorry, I got just my power went off, so couldn't able to connect.
Hmm. Okay, then
Yeah,
maybe.
I was on the third expression, and you have divided it, and you got yeah. Uh, okay, so again you have substitute that I2 in this. Okay, fine.
Yeah. Okay. So I have found that I3 comes out to be 2.7037 ampere. Okay. So now I want to find the remaining quantities. So I've got I3, I can find I2. So I2 is what? 2I3 minus I4. So that is 2 into 2.7037 minus 4. So calculate and tell me how much this is.
Sir, I2 is 1.407 ampere.
Okay. What about others? Others are not calculating or what? We have to calculate it.
1.4074.
Okay. Yeah. So, has anyone actually given the NPTEL exam for any other subject?
No, sir. No, sir.
Okay. Others, has anyone given? Because I don't know whether you guys are allowed calculator or what type of calculator is provided. So
Online calculator is allowed.
Online calculator will be their basic version, which we can use there.
okay.
I've given for power electronics.
Uh-huh. Okay. For power electronics also, you just were given that online calculator like that gate type of calculator, right?
Yes.
Okay. 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 Mhm. All right. So in that calculator you cannot do this matrix inverse. All those things are not possible, right? Like inverse of a matrix or solving equations, simultaneous equations. Those are not possible, right? Because I have
Advanced
this.
features will not be
Sorry,
there.
sorry.
Only basic features will be available. So we have to do it through.
Okay. Okay. Yeah. So that's why you'll have to use this sort of method. Okay. You have to substitute and eliminate in such a way you will get the values. Because you cannot just solve it like if you have this sort of calculator. If you have like this calculator, uh, you could probably in these scientific calculators are allowed in your BTech semester exams. They are allowed, but in this GATE exam, these are not allowed. So you have to learn how to write the equations in such a form to simplify so that you can get a quantity, unknown quantity you can find. Okay. So now you have found out I2, I3 you have found, I2 you have found. Next, you want to find I1 also, you want to find I4. You know I1 is 3 ampere, I2 you have found, I3 is found,
Yes,
you
sir.
want to find I4. I4 is simple, I3
Four
plus 2. So your I4 will
4.7037 ampere.
4.7037.
37 ampere.
Okay. Yeah.
Yes, sir.
Okay, so this is the calculator. Huh? Let's check. So slow. Okay, let this calculator come up. We'll see till then. So I have found I4, I3, I2. Now I'll again paste that. Okay, let us go to the next page. Okay. So this is my question. Now this is my circuit. Now they tell me so okay, let me draw the currents again. So this is I1, this is I2, this is my I3, and this is my I4. Okay. So now I want to find the currents. Now I found the currents. Now I want to find what is the plus or minus voltage drop across this 3 ohm resistor. That is my V1. I want to find V1.
I1 minus I2 whole into 3.
Okay. So let me zoom in a bit. Okay. So if you see this, what is happening? Current is flowing like this. It is going like this. So it will be this V1. This is important because here people make errors. This V1, this voltage drop across this resistor is equal to the current flowing in the downward direction into the resistance. So that is equal to I1 minus I2 into this 3 ohm. This is 3. So I1 I know is, so this is important. How this is come, does anyone have any doubt? In this, no one has any doubt. V1 is equal to I1 minus I2 into 3. Okay. So I1 is 3 ampere. So I1 is 3 amperes. So it will be 3 minus I2. I2 is how much? 1.407. So who is there? Pavan. Okay. Ayush Sharma. Can you tell me what will be V1? Subrajit Chowdhury. Nisbah. Tell me what will be V1?
4.77.
4.77. 4.77. 4.77 what?
Volts.
Yeah, that is important. Okay. So it is 4.77 volt. Right? So now we have to find the V2. V2 I want to find. So what will be V2? What will be the equation of V2? Let me ask someone. Bharat Srivastava. What will be the equation of V2? Hmm? Why Bharat? What about others? What is V2?
5 into I2 minus I3.
V2 will be 5. That is the resistance over here. So plus and minus. See the equation, the polarity is important. So I'm going from here to here. So 5 into the current going in a downward direction. That will be I2 minus I3. So what is V2? What is the value of it?
Minus 6.48.
Minus 6.48 volt. Okay. Let me just check. No, minus 6.48. Okay, so I found V1 and V2. Now, can anyone tell me what is the voltage across the current source? Across this current source 3 ampere. Okay, what is the voltage over here? What is the voltage?
Ten plus V1.
Okay, so voltage 3A is equal to 10 plus V1. How I get it? How do I know? Verify that this is correct. I apply KVL. I go from plus or minus. See, I have given this is plus, this is minus. So V3A plus minus V1 minus 10 is equal to 0. So when I take 10 and V1 that side, it becomes like this. Okay, so how do I verify that? So I apply KVL over here. So I do minus to plus. So this becomes V3A plus to minus, so it becomes minus V1 and plus minus, so it becomes minus 10 is equal to 0. I take this to this side, take this to the right hand side, and I get V3A is equal to 10 plus V1. Okay. Any queries on this? So
14.77.
it comes out to be 14.77 volt. Now, the question asked me, how much is the power delivered by the 3 ampere source? 3 ampere current source. What will be the power?
Voltage into current.
Yes. So
14.77.
that will be voltage 3 ampere into the 3. Okay, so that is 14.77 into 3. That comes out to be 44.31 watt. Okay, watt. That is the notation. Now, does this mean that the power is being, is this that this current source is delivering power or it is consuming power? How will I know? Can anyone tell me?
delivering the power.
Why?
The direction of the current is out from the positive.
Okay, no. This is for a current source. So for a current source, where your current is flowing out, there it should have a higher polarity as compared. That is, it should be positive. Okay. What you said is correct, but I'm just saying that for a current source, you first consider the current as the important direction, that the current is flowing out of it, and then you consider voltage polarity across it. Okay. Or is there any confusion in that? So that's how I found the power. Okay. Next, I want to find the power from the 20-volt source. So what will be that power be?
The current is I3, so 20 into I3. 20 into 2.7037.
Okay, so why we consider just I3 is because the current is flowing out from the positive terminal. Okay, from the positive terminal. Okay, and then we consider, otherwise we have to consider negative sign. It depends. Okay, so current is flowing out of the positive terminal of the voltage source, so we consider it to be positive. So I3 into 20, that comes out to be how much? 20 to 2.7037. That will come around some, how much? 54 something.
54.074.
Okay. So it is
Watt.
54.074 watt. Okay. Now can you tell me what is the, so this is the power delivered. This is the power generated by the voltage source. Okay. Can you tell me what is the power being generated by the 10-volt source?
10 into I1 minus I4.
Okay. Into?
10 into I1 minus I4.
Okay. What about others?
I4.
Sorry, I4 minus I1. I4 minus I1.
Yes, it will be I4 minus I1. Why? Because current should flow out.
I4 is greater than I1.
No, not because I4 is greater than I1. It is because we are considering the polarity, that is the current. We are considering the current flowing out of the positive terminal of the voltage source. That is the what. Okay. Based on that, in case, so it is 10 into I4 minus I1. What that comes out to be? 4.7037 minus 3. That comes out to be 1.70. So it comes out to be 17.037 watt. Calculate and check.
7 minus I1 is 3. Mm-hmm. 17.037.
Yes. Anyone has doubt in this? Okay. So this is the power being delivered or power being generated by the 10 voltage source. Assume in the question they ask what is the power being consumed by the voltage source, then you should consider current flowing into the positive terminal of the voltage source and then it will be minus. Okay, it will be minus.
That's it.
Okay. Now, what is the power being consumed by my 5 ohm resistor?
Phi into I4 square.
Okay. The power being consumed by my 5 ohm resistor is, okay, let me move. Phi into I4 square. So what is I4?
Sir, please 1 second.
Yes.
Sir, the power across the 20 volt source is also negative as the I3 is entering at the negative.
But I3 is flowing out of the positive, right? That we consider for the positive terminal.
Sir, in 10 volt is also the I4 is out from the positive terminal.
No. Yes, I4 is coming out. Yes.
Yes, sir. So why, sir, it is negative?
It is not
If
negative.
in 20 volt is positive, then in 10 volt, why negative?
Yes, it is positive only. I'm just saying.
Sir, you say that minus 17 0.
I'm
Sir,
saying
you said that minus 17.037 watt.
this is the power delivered or generated. Okay.
Sir, in 10 volt.
Yes. If they ask in the question what is the power consumed, then it will be minus. If they ask what is the power being delivered, then
Yes, sir. Yes, sir. Power consumed. Yes, sir. Yes, sir. Yes, sir. Yes, sir. Yes, sir. Yes, sir. Yes, sir.
Okay.
Yes, sir. Yes, sir.
Okay. So what is the power being?
Sir, 3 ampere current source is also delivering the power.
That you'll have to check. You'll have to see how it is delivering power. This delivering power.
Yes, the current is entering the negative terminal out from the positive terminal. So the 3 ampere is also delivering the power.
Yes.
But if the question is consumed, then that is negative.
Yes.
Yes, sir. Yes, sir.
Okay. Now, what is the power consumed by the 5 ohm resistor? Can you calculate and tell me?
Sir, 5 ohm is I3 is greater than I3 minus I2. I3 minus I2 whole square into 5.
Why?
I3 minus I2 whole square into 5.
Because the 5 ohm resistor is just I4 square into 5, no?
Sir, in 5 ohm, there is two currents flowing. One is I3 and another is I2. So I3 minus I2 whole square into 5.
Oh, you're
In 5 ohm
considering.
resistor.
I'm considering this 5 ohm.
Sir,
I'm considering this bottom.
sir. Okay. Sir, only sir, I4 square into 5.
Yeah. So what is that value?
Sir, I4 is found at 4.70.
22.124.
I4 is 4.7037 rho square into 5. 4.7037 rho square into 5. 110.623.
Yes. So 110.623.
0.623 watt.
Watt. Okay.
Yes, sir.
Yeah. So
I3 is 2.7037 minus I2 is 1.4074. 4074 whole square into 5. So 2.7037 minus 1.4037. That is the square into 5. It's 40 watt.
okay. So
Consumed.
what about others? So others have doubts? Any questions? Pratish.
Could you
Yes.
could you please give us that equation for the super mesh?
For the Supermesh. Okay. Supermesh. So Supermesh is here. This one, right?
Yeah, correct.
This one,
In
right?
the same problem we have discussed. Can you come down?
Okay. Yes.
Here. So for these equations, loop 1 anyway, I1 is 3, that is clear, and I4 minus I3 is clear to me. But why we need to open the 2 ampere source when we are calculating super mesh? So is there any specific reason why we have to do that?
See, you don't know what is the voltage across the 2 ampere source. You know what is the
Right.
voltage across a battery, that is 10 volt, you assume. It is given. You know what is the voltage
Right.
across a resistor because it is the current into the resistor. But across a current source, you don't know what is the voltage across it. So if I go to
Right.
apply KVL over here, I can get till 10 volt, I
Mhm.
can get. Then I come here. Then what is the voltage across the 2 ampere current source? I don't know. So I cannot use it.
Mhm.
I can't just get stuck over there. Okay. Similarly, if I apply KVL in this in this mesh 3 across the 5 ohm resistor, I can get the voltage. Across this battery, I can get the voltage. But I cannot get the voltage across this current source. So to overcome this problem, what you do is you take the KVL across this entire super mesh. Okay. You take the KVL across this
Mhm.
entire super mesh. And that gives you one equation. And then you solve that equation. Okay.
Okay.
So see, basically, look at in this manner. You have mesh 4, mesh 3. In the normal mesh
Mhm.
analysis, you get two equations from these two meshes. In our super
Right.
mesh analysis, also you're getting two equations. One is you're
Mhm.
applying KVL across this entire super mesh. Another is this I4 minus I3 is equal to 2. This also equation you're getting. So
Yes.
effectively, you're getting two equations which you need to solve.
Mhm.
Hmm.
I mean, my question is more towards like wherever we have super mesh or super node,
Uh-huh.
we are shorting the volt for the
No, no,
super
we are
node.
not
And
shorting. We are not shorting. We are not changing it. It is there in the
uh-huh.
circuit as it is. See, if you consider like Thevenin's theorem, Norton's theorem, there you're doing the shorting or opening, that is different. Here you're considering
Okay.
that it is still a part of the circuit, it is untouched. But you're
Okay.
what you're doing is you're not finding the voltage across it. See, KVL is valid across any loop. KVL is valid across any loop. Mesh analysis,
Right.
consider the mesh is the smallest loop, okay, the smallest possible loop. But KVL also is valid for a dual loop. For a larger loop, it is valid. So so because I'm doing mesh analysis, I find out that I have a super mesh and I cannot apply KVL to those individual meshes. I find the KVL of the entire super mesh. Okay.
Oh, you mean to say that cumulative effect, that's what we have already taken out I4 minus I3 is equal to 2. So
Ah,
that's why we don't want to. Okay.
yes.
Okay.
So that current source is not being shorted or anything. It is still as it is.
Right. Right. Understand.
Hmm. Yes. Okay. Then any other queries? Mhm. So all of you are experts.
No, no, maybe while solving only we'll face many issues, not
Yeah,
by
yeah.
listening to.
Mhm. Yes. So actually, the way, okay, someone's asking. Okay, thanks. So the way to solve is like you can attend many sessions, you can see many videos, and you will think you know, but you don't know. You have to individually, you have to like open a fresh notebook and see the question, not see the answer, not see the solution, and just solve. Okay. So this is like sort of like maths. So okay, okay. Yes, I'll come to that, Britika. So you have to individually you have to solve. You cannot like just read up and try to remember. Once you solve multiple things, then it becomes easier to do. Okay. So Britika has a question: what is the power generator and what is the power delivered? Okay, so let me consider a new circuit. Assume I have this is plus minus V1. Okay, and this is my R1, and this is my plus minus V2. Okay, and this is my current I1. Okay, so Vritika, what is the current I1? Vritika, right? What's the name? Vritika.
V1 minus V2 by R1.
Yes. Let us give some numbers also. So assume R1 is 10. Assume V1 is 20. Assume V2 is 10. So what is I1? So I1 is
1 ampere.
V1
1
minus
ampere.
I1. So that comes out to be 1 ampere. Okay. Now we will
Yes, sir.
So look at it this way. So what is the power now for this V1 voltage source? Power, let us consider P1. Okay, P1 is the power being power.
Yes, sir.
That is equal to V1 into I1. So what is that value?
I1.
Hmm?
20. 120. 120, 20 watt.
20 watt. Okay.
Hmm.
Power 2 is the power across this. How much is that?
10 watt. Minus 10 watt.
V2 into I2. Let us not consider sign. Let us just consider V2 into I2. This is 10 watt. Okay. What is
10
the
watt.
what is the power consumed? What is the power in this resistor? PR1.
10 watt. 10 watt.
That is equal to I1 square R1. So that is 1 square into 10.
10
So
watt.
10 watt. Okay. So now,
Yes.
who is generating the power and who is consuming the power is what we want to know. Okay. So in this, so the resistor will always consume the power. Resistor cannot generate the power. So the power which flows, the current which flows to the resistor, it generates heat. It generates thermal power. If you would have observed in your experiments, etc., rheostat, resistance, etc., when current flows through it becomes hot. Okay, it becomes hot. So PR1 is power being consumed. It is being consumed by your resistor. Okay. Now we are left with two things, P1, P2. We don't know who is generating power. We don't know who is consuming power. So the convention is that if from the positive terminal of the voltage source, the current is flowing out of it. Okay, here current is flowing out of it. That means it is generating the power. It is the one which is creating or generating the power. So this is the generating the power, or it is the one which is delivering the power. Okay, it is the one which is delivering the power. Okay, let me generating, delivering. Okay, now you see for V2, it is the current is flowing into it. Current is flowing into it. So it is the one consuming the power. So this is the one consuming the power. Okay. So the convention is if the current is flowing out of a voltage source, that means it is generating the power. If the current is flowing into the voltage source, that means it is consuming the power. So I hope this answers your doubt, Ritika. Hmm. Okay. Then any other queries or doubts? So, so actually, Shivani, you are struggling to join and all. So if you have whatever you have missed, also it actually this will be uploaded on YouTube, so you can check it out. And for others also, this I will upload these videos on YouTube. So I've shared the link of my one minute. It is there, right? So the links are there. The channel link is there, and the drive link is there. So in my channel link, I am going to upload the videos which you can access. And this is the drive link where these notes will be added. Okay, and one more thing about this TCS thing is not coming. It's not working. Okay, this is not working. Okay, let it be. So you have a gate calculator, so you have to consider, you have to solve problems considering that. Okay. Anyone, any other doubts, or we can end the meeting?
No, sir, no.
Okay, what about others? All Shivani, Pratish,
One time
Ayush.
I can explain.
What Ayush? I can't hear. Ayush?
Sir, one time you can explain supernode what is that?
Okay, Supernode. Okay. So this is Supernode. Okay. So there is node A and B, and there is a voltage source connected between them. So we don't know what is the current going through this voltage source. Okay. So what we do is this node A and this node B, we club them and consider it as one super node. Both the nodes are not joined. Both the nodes are still separate, but we club them together and consider it as one super node. And then the same concept which we apply KCL to the entire super node. So what's the convention which I follow is I consider that all the currents are flowing out of the node. So we'll consider that all the currents are flowing out of the super node. So current is flowing out here, current is flowing out here, current is flowing out here, and current is flowing out here. And I write that equation and I consider that this current plus this current plus this current plus this current is equal to 0. Right.
Okay.
Okay. And also we showed that if you apply this what do you say? You apply KCL at this node and then KCL at this node, then you have to eliminate this IX and then you have to solve. So instead, we directly apply KCL to the entire super node to save us time. Yeah. So you guys are like, let me just ask, let me find out. You guys can tell me. So Suresh, you're from which, you're studying, your student, you're from which college?
No, I'm not a student.
Okay. Okay. What about Shubham Hota, Pawan B? Like you can tell me like what exactly is it, like why are you learning this? Is it for gate preparation or is it for your BTech exams? Like what?
Sir, for gate preparation.
Okay.
I am attending the class for gate preparation.
Okay. Pawan? Okay. Britika?
Sir, I'm a student from Techno College of Engineering, Agartala.
Okay. All right. So Subrajit Chaudhary?
Yes, sir, I'm a student.
Okay. All right. Okay.
Well, myself, Pawan, I'm a scholar, research scholar.
Okay. So Ashwath, okay.
I'm sorry that my internet is very laggy, so I couldn't able to get these things. Will this will be available in YouTube, na?
Yeah. I put the link actually.
Yeah. Thank you.
So I will upload it. It takes some time for me to upload everything.
Okay.
What about Ashwath Salaskar? Okay. What about Shivani?
Yes, sir, I'm a student.
Okay. I'm going to reshare the link. So let me know share it. Let me combine the